Nuclear Renaissance, Fact or Fiction? This presentation will present facts of the nuclear power industry in Asia to provide or not provide evidence as to if a nuclear renaissance is occurring throughout Asia. This is to meet the requirements of the Thomas Edison Nuclear Capstone project. Additional team members are Kyle Hollis and Dean Humphreys, who have provided significant input to development of my presentation. I am Rodney Rodriguez, and we will discuss our objectives. Our objectives are to discuss the status of power reactors in Asia, review statistics of power reactors in Asia, to discuss significant events affecting the nuclear power industry in Asia, discuss the nuclear share throughout Asia, and to discuss factors affecting development of nuclear power in Asia to focus on efficiency and carbon emissions. We will also discuss significant advancements in reactor plant designs, which will include China's thorium molten salt fast reactor liquid fueled project, India's comprehensive thorium fuel cycle, Japan sodium-cooled fast reactor, South Korea's prototype Generation 4 sodium-cooled fast reactor. We will mention the integral fast reactor design based on US design, and we will just mention the overall development. Additionally, we will discuss high-level waste concerns, which will include storage, disposal, and vitrification. And finally, we will summarize an outlook on the nuclear power industry in Asia. The most notable references I have used to develop my capstone project came from the World Nuclear Association and many subordinate web pages, and the International Atomic Energy Agency's Power Reactor Information site. Additionally, my training as a nuclear operator in the United States Navy and the continued education that has provided me insight to the nuclear power industry and development of nuclear reactors. There are many more sources that were vital to complete my capstone project and support evidence I discovered. First, power reactors in Asia. Below is a graph that has been compiled from data from the International Atomic Energy Agency Power Reactor Information System website. Asia currently has 135 operating nuclear reactors throughout the continent. Many of these reactors are light water pressurized water reactors. China and India currently dominate the industry, with China having the significant lead. They take this lead with the number of reactors that have been planned and proposed. Japan currently has 42 operable nuclear power plants, but not all 42 are operating. Only 25 reactors have been granted restart approval and are still awaiting restart, and another 4 reactors have actually restarted. And of those 4 reactors that have restarted, only 2 have resumed commercial operations. Notable industries in Asia are Iran, Pakistan, and Taiwan. Taiwan is notable for its great political opposition to nuclear power, to an extent of which 2 recently constructed plants have been mothballed and no restart is awaited. No further plans are approved or proposed in Taiwan. Pakistan has the first reactor which has been restarted since the Fukushima accident, Chasnut 3 plant. And Iran and its Bushehr 1 plant has been the first nuclear power to emerge throughout Asia in recent years. The nuclear share. The data below has been provided by the World Nuclear Association, and it has covered the period from 2004 to 2014 of nuclear share production. Nuclear share is a percentage of electrical power production, which is derived from nuclear power. Overall, there has been a decrease in nuclear share throughout Asia, and that would be to exclude Japan from this figure. The sharp drop from Japan is due to a shutdown of all plants after the Fukushima incident and its nuclear share percentage is only incidental of that. Even though the nuclear share has been declining in Asia, it may not necessarily mean that nuclear power plants are not being constructed. Simply, it means nuclear power plants are not being constructed or contributing to electrical power production at a rate that would counteract the increase in electrical power consumption. Currently, electrical power consumption in developing countries such as China and India is growing more and more every day, and reactor plants cannot be built fast enough at a realistic scale to combat the rising consumption needs of electrical power. Although the nuclear share throughout Asia continues to go down, world electrical power consumption continues to go up, particularly throughout Asia and developing countries. Below is a graph by the Energy Information Administration, which shows predicted power generation rates until the year 2040. The world nuclear share is predicted to slightly go up and slightly plateau by the year 2040. But this does not mean that the building and construction of nuclear plants has been stalled. This is simply because the rate of electrical power production and consumption is going up faster than the nuclear industry is building their share of reactors for electrical power production. Some documents, such as the BP Energy Outlook year 2016, have predicted nuclear share rates of Chinese, Japanese, and Korean nuclear power industries to as much as triple by the year 2060. This is a clear indicator that Asian countries have a vested stake in their nuclear power industry over the next several decades and are truly becoming world leaders. Recently, the Japanese nuclear power industry has come to be known and defined by the events of the Fukushima accident. The Fukushima accident led to the destruction of several reactors and a complete shutdown of the Japanese nuclear power industry. Only several reactors have restarted since the Fukushima accident in Japan, and recovery efforts are still in progress. Even though the Fukushima accident was heard around the world, many are unfamiliar with the other aspects of the Asian nuclear power industry. No other nuclear accidents in Asia have occurred as a result of a nuclear power reactor operational accident. This excludes Russia. Presented is the International Nuclear Event Scale, provided by the International Atomic Energy Administration. This scale ranks incidents and accidents in the nuclear power industry amongst each other. Accidents are level 4 and above, incidents are level 3 and below. In comparison to Fukushima, Asia has not suffered an accident and has only had incidents throughout other countries. The most notable incident was a turbine hall fire in India, which resulted in the compromise of safety features, placing it at a level 3. China is known to have no incidents above a level 3. The South Korean nuclear power industry has an impeccable record. Recently, the South Korean nuclear power industry had discovered several uncertified parts had been installed in some reactor plants. These reactors were shut down, officials were indicted, and charges were filed against them. No other notable incidents or accidents are known to have occurred in Asia. This excludes Russia. Nuclear power has several publicly appealing aspects. However, we will discuss two. The first publicly appealing aspect is reduction in carbon emissions. The second is the efficiency of nuclear power. Reduction in carbon emissions is very appealing to the public due to many political factors and environmental factors, and efficiency stands for itself. Carbon emissions. According to the World Nuclear Organization, nuclear power ranks amongst the lowest of CO2 producing power sources. Nuclear power may even be the lowest ranked CO2 producing power source according to some estimates. Many groups are concerned about carbon emissions due to environmental factors, and many scientific theories support that reduced carbon emissions can improve the environment. These scientific theories have gained much political support and support from the public. Nuclear power provides an alternative to many hydrocarbon power sources, while reducing CO2 production and operating at the same capacity. Energy return on investment. Energy return on investment is a unique way to give an overall industry evaluation on efficiency based on many factors, such as resources input, capacity factor, initial investment, and many others. According to the World Nuclear Association, nuclear power ranks as the highest electrical power production source as far as energy return on investment is concerned. This means nuclear power is not only efficient in plant design, but economically efficient in many circumstances. Efficiency can be measured on many scales, but energy return on investment measures the efficiency on a scale of is it viable. Nuclear power is 10 times more viable than any other power source that you see here when you compare it to the baseline of breaking even. Clearly, nuclear power is a preferred power source if you were to choose a power source to be economically and commercially efficient. Recently, the nuclear power industry has seen many significant advances. In fact, the advances have not stopped. Most of them have been done on paper. However, some countries have put these theoretical plans into action. And some of these significance are breeding of thorium into a fuel, actinide burning, and molten salt technology. Several significant plant designs have been developed throughout Asia due to the desirability of nuclear power. China's liquid-fueled thorium molten salt reactor project, India's comprehensive thorium fuel cycle, Japan's sodium-cooled fast reactor, and South Korea's prototype Generation 4 sodium-cooled fast reactor. Of all these designs, currently none are operational. However, China is near complete in construction of its first thorium molten salt reactor. This first reactor is to evaluate the use of thorium as a fuel and to evaluate the use of liquid salt as a coolant. The next step in China's thorium molten salt reactor project is to have liquid fuel entrained into salt by being chemically dissolved. This will allow for easy chemical reprocessing of the fuel and continued reactor operations. And the last stage of China's thorium molten salt reactor project is to incorporate a fast neutron spectrum to more efficiently burn actinides and other fission products prior to fuel disposal. India's comprehensive thorium fuel cycle has also seen advancement in its first stages by producing thorium. This thorium has been produced in pressurized heavy water reactors and is planned to be used for future operations in their entire proposed reactor fleet. India's comprehensive thorium fuel cycle is a large part of responsibility for the proposition of an entire fleet of complementary reactors to develop thorium as their main fuel source. Japan and South Korea are both developing fast reactors. These fast reactors are being developed to more effectively burn actinides and other fission products to more efficiently dispose of spent fuel. This will provide great benefit to fuel storage in Japan and South Korea's future. Overall, developments in Japan's, South Korea's, India's, and China's nuclear power industries all focus around fuel sourcing or fuel disposal. Since many reactor plant designs in Asia focus on fast neutron spectrums, disposal of actinides, and safety, discussion of the molten salt reactor experiment is appropriate. The molten salt reactor experiment by the United States was developed to ultimately place a nuclear reactor inside of an aircraft to power it. This reactor was designed to be inherently safe at higher temperatures for better efficiency and lower pressures for a reduction in the number of required safety features. Overall, the molten salt reactor experiment led to a plant which was small, efficient, and safe. Additionally, it provides a fast neutron spectrum which will be beneficial for our next discussion. This fast neutron spectrum can be very beneficial under correct circumstances. If thorium is used as a fuel and a fast neutron spectrum is maintained, thorium can be bred into uranium-233, essentially turning a non-radioactive and non-fissionable source of material into a fissionable fuel for a reactor plant. This molten salt reactor plant design was proposed by Flibe Energy. Differences are, the United States molten salt reactor experiment used water in its secondary systems, and the Flibe Energy design of the molten salt reactor plant uses CO2, compressors, and turbines for a supercritical cycle. Additionally, improved safety features such as a drain tank have been installed to this design. This drain tank provides a shaped source for fuel to drain into to ensure no inadvertent criticality can take place. Overall, both the molten salt reactor experiment plant design and this reactor plant design by Flibe Energy are the closest indicators of what China's liquid-fueled thorium molten salt reactor plant may look like. This plant provides many advantages over conventional nuclear power plants. For many decades, nuclear power plants have been producing waste. The majority of this waste is in high-level nuclear waste. This high-level nuclear waste is spent fuel, which contains fission products, and unused radioactive sourced fuel. This fuel is highly radioactive and highly dangerous. It requires the most safe disposal method accomplishable. Currently, fuel is stored on-site in cooling pools at nearly every nuclear site throughout the world and in Asia. This has led to a buildup of nuclear waste. Currently, the final solution for disposal of nuclear waste is deep underground storage and geological repositories. Waste disposal sites are limited, and when constructed, they must be proven to be impenetrable to groundwater, corrosion, and many other factors to ensure protection of and isolation of the nuclear waste for hundreds of thousands of years. Currently, nuclear waste from conventional reactors will take hundreds of thousands of years to decay. Two factors may make this waste more safe to handle after use. Use of fast reactors to burn actinides off, and vitrifying this waste will prevent spread of its effects. Vitrification. Vitrification is a process of turning a substance into a ceramic or a glass. Ceramics and glass are known for their low chemical reactivity, making them ideal candidates for spent nuclear fuel storage. Additionally, ceramics and glass undergo less erosion under harsh conditions as compared to other storage methods. Ultimately, any vitrified substance is going to interact very little with the outside environment, especially in the center of that substance. This makes vitrification a very attractive way to dispose of spent nuclear fuel by ensuring low chemical reactivity, high mechanical stability, and little effects if mechanically disturbed. Currently, long-term plans throughout Asia are deep geological repositories which store vitrified nuclear waste for the ultimate way to dispose of spent fuel. In summary, Asia has a large fraction of nuclear power plants operating throughout the world. Many more are under construction, planned, proposed, or awaiting restart. These nuclear power plants significantly contribute to the nuclear share throughout Asia. Although nuclear shares may be declining in many cases, total energy production by nuclear power is going up, while electrical consumption percentage is going up as well. This will ensure nuclear power remains a significant and relevant source for electricity throughout the next several decades. It is also an attractive source of electrical power production due to its carbon efficiency and its overall efficiency. Reduction in carbon emissions ensures public support from several different groups, and efficiency ensures continued operations with economical benefits. Significant advancements have been made due to these attractive features in nuclear power, such as breeding thorium as a fuel, actinide burning, and molten salt technology, which have led to several plant designs, most notably China's liquid-fueled thorium molten salt reactor project and use of India's comprehensive thorium fuel cycle. These two significant contributions to plant design will most likely resemble molten salt reactor plant designs proposed in the past. These designs and developments throughout Asia will overall aid in fuel sourcing and waste disposal and efficient power plant operations at higher temperatures and lower pressures, ultimately resulting in safer plant designs. Is a nuclear renaissance happening in Asia? I believe so. There may be some minor operational contributions at this point, but if everything goes as planned and proposed, Asia is definitely set to be one of the nuclear leaders in the world.